So how can this fascinating technology of the Mach reactor be effectively applied to mineral processing? Well, there are two applications that have emerged as hot favorites, one being that of flotation enhancement in PGM concentrators in South Africa. In particular, more effective flotation of valuable fines. And the other being that of pre-oxidation and boosted leaching in a gold application, as well as improved mass transfer for cyanide destruction processes. Let's talk about the flotation application of the Mach first. There's an optimum size range for conventional flotation, where flotation efficiencies are relatively high. This varies between commodities and ore types, but it is generally accepted that a size range of 45 microns to 150 microns will float well, with the finer fractions below 45 microns floating slowly and with poor recovery. The real challenge emerges for particle sizes below 25 microns, and particularly below 10 microns in size. The Mach targets these poorly floating fines, which are usually well liberated. By improving the recovery of these fines, both concentrate grade and recovery is improved. Selectivity is also improved by accelerating the kinetics of the slow-floating valuable fines, but not the fine gangue. This results in a reduction in mass pull and improvement in concentrate quality. The following animation explains this concept further. First, we will see the successful flotation of an optimally sized particle with successful attachment. Then we will see the unsuccessful flotation of a fine particle with no attachment. And finally, the successful flotation of fines by pico-bubble nucleation directly on the fine particles in the venturis of the Mach, followed by aggregation of the fine particles and successful attachment and flotation of the aggregate. But what if the mountain does not come to Muhammad? In other words, what if we are unable to generate pico-bubbles directly on the surfaces of hydrophobic particles in the cavitating venturis of the Mach? Well then, from classical flotation theory, the tiny bubbles generated by the Mach reactor would result in an increase in SB values, which in turn would lead to faster flotation rates. Also, the exponential increase in turbulent kinetic energy dissipation rate as the speeds in the venturis of the Mach approach choke velocity would have the effect of increasing the shear rate, which in turn would increase flotation rate.